Hey everyone, this is Ahsan, and in this video we are talking about Web 3.0. So I'm following this course from buildspace.so, and this is about Solidity, Ethereum, and how to actually create your own project and push that to blockchain. So in this video you're going to learn a lot of things as we go through those problems. You can always do this on your own, but I actually got stuck in a couple of places and I thought it might be useful to share that knowledge with you so you find this easier. So as always, like this video, subscribe if you have not already, and let's get started. First of all, I need to share this link with you. This is called buildspace.so. So this is essentially a website which has some really good tutorials on Web 3.0, and I stumbled upon this one quite recently. And this is something I want to explore as well, learn as well as we go forward. But essentially all you need to do is go there and first create your account. Once you set up your account, you're going to have a couple of projects to work on. So there are a couple of projects here, like this is a 2-week project, this is a weekend project, so it looks like this is going to be finished soon. All right, so we can start with this first application. We could pick all of those. We can also have like this NFT browser game. We could also have this game, but we need to, I think, first start with the first one, which is this one. So it has like a lot of sections, completely fine. So what you need to do is you need to go to help.buildspace.so. You need to create an account on this one, and then you can pick one of the projects. The project that I have picked is this one called Solidity, or building a Web3 with Solidity and Ethereum smart contracts. You need to open this, and then I think you can get started. We're going to follow this step by step. I'm going to be using my own app that I created for sort of the productivity for this one. Focusdoro.app. All right, so 25 minutes of focus time, and now let's get started. So focus time. Let's keep this open. All right, let's see. So first of all, we are going to write and deploy our Wave Portal smart contract to a local Ethereum network, which means that we are going to connect our Discord in the project dashboard, connect your Ethereum wallet in the project dashboard, miss kickoff. This is going to be awesome, blah, blah, blah. All right, so that is about the kickoff. That's fine. So get your local Ethereum network working. So let's do that. Before anything, we are going to create our network. Okay, this is how we can compile and test our smart contract code. So we are going to write a smart contract. Our smart contract will be deployed to blockchain, and then we are going to build a client website that will let people easily interact with our smart contract on the blockchain. Alrighty, issues throughout here, drop a message on Discord, section 1 help. They have a really good Discord called Build Space, which is this one. And there we should have a section 1 help here. So there's a channel called section 1 help that we can reach out to. So I'm going to share the invite link with you. So this is their Discord link. So now that we have that, let's see. We're going to use a tool called hard hat a lot. This will let us easily spin up local Ethereum and fake test account to work with. Okay, just like a local server, except the server is the blockchain. Okay, quickly compile smart contracts and test them in your local blockchain. First, you need to get node npm. We already have node.js installed. So setting up the environment on Windows, you get installer. This is, I think, Git. So you need to also install Git. What else? And then you need to install with node.js. All right, then we just need to create a new folder and then get started. So we're going to create this into desktop, and then we should have work, and then we have go towards experiments. So experiments, and then we are going to do mkdir wave portal. So we are creating a new folder here. Then we cd into it. Then we do npm init y and npm install hard hat. So npm init y, which will create a file for us, a package.json, which is used for installing packages. And then we just need to do npm install save dev hard hat. And then we just need to run npx hard hat. I'm going to kind of zoom this a bit so you can also see. All right, so this is currently being installed. And I think once this is installed, we should be able to get our server running. And then we have other things as well to install. So now we need to run npx hard hat, and it says create a sample project. Okay, so maybe a basic sample project. Hard project root my wave portal. Yes. Do you want to add a git ignore? Yes, please. Help us improve. Yeah, for sure. Project created. See the readme file for example. You can run. Okay. Now I'm going to open this into Visual Studio Code so we can take it from there. So Now we need to run npx hardhead. We already did that. Now we need to install these things into our project. So I'm going to open a terminal and then I'm going to install these dependencies. We are adding hardhead waffle, ethereum waffle, chai, hardhead ethers, and ethers. Finally, run npx hardhead accounts, and this should print out a bunch of strings looking like this. These are ethereum addresses that hardhead generates for us to simulate real users on blockchain. Okay. All right. So what's happening here is we are creating a project using hardhead. Then we are also creating fake addresses for blockchain. And remember, each address here is a user. So just like you and I have email and passwords or our phone numbers, and we log in into different websites using our emails, in blockchain, we talk using addresses, or we talk using these accounts. You don't need to remember your email and password. You can connect with your wallet or your account. So these are fake accounts into my local machine. They're not on the blockchain. They're on my local version of blockchain, which is not on the internet. So that means I can finally run this final command when this is done. So it's still installing a bunch of packages right now. Let's see. It looks like it's almost installed. Yay! So after installing these ones, we just need to run npx hardhead compile. So we are going to run this. So again, everyone, this is just a bunch of prerequisite for getting started. We have not started coding still. All right, so we got this. Let's share this in the progress channel as they mentioned. I'm gonna copy this, close this, and go and paste in the submit terminal screenshot. Oh, so we are going to start out with the structure every contract start out with. So what we need to do is, let's build a smart contract. Let's just send a wave to our contract and keep track of total number of waves. This is going to be useful because on your side, you want to keep track of this. Okay. Create a file name called waveportal.sol. The language used for creating those smart contracts is called Solidity. And we are not coding in JavaScript, but it's called Solidity that we are using. So we are going to create a file called waveportal.solidity. And then we need to go to our code, and in the code we have contracts, and here we should have a welcome.solidity. And in welcome.solidity we can now create our contract. So when we talk about smart contracts, that's just functions or functionality. So for example, if I want to say hi to someone, that's a functionality. So that will be a smart contract. If I want to get message from someone, not message, but let's say if I want to post something on the blockchain, that's a smart contract. If I want to update something on the blockchain, that's going to be a smart contract. So we are going to start out with the structure every contract starts out with. So we have like pragma solidity something something. So I'm going to go and kind of put this here. And also there's one really good thing that they mentioned, that we need to also have some sort of extension installed. So we have created, first step, we have created a file. Second, they said that install this extension, Solidity extension. So we can install this into our VS Code, click install. That means that right now you see this all black and white. This should potentially make it colorful so we can see and identify our code in a better way. That's what I think. All right, so this is installed. And now you see it's colorful. Yay! So that is the whole idea of installing an extension that supports language. We have pragma solidity, which means that this is the version of Solidity compiler we want our contract to use. It basically says when it's running is, when running this, I only want to use version 0.8 of Solidity compiler, nothing lower, to be sure that the compile version is the same as head config. Okay, this is the version of Solidity we already discussed. Then we need to import console Solidity. Close this guy, close here, and then already we are already importing the console here. Then it says console.log yo I'm in contract and I'm smart. All right, so it seems like this is a version of JavaScript console log, but it probably logs inside somewhere. Maybe it just uses console log. Let's see. So we import this, some magic given to us by hardware to do some console logs in our contract. It console logs in the contract, and then we cannot debug those contracts, but this is one of the goodies. All right, so that means that I'm not going to be able to put breakpoints, but I can still do console logs, which is probably the easiest way of debugging. So smart contracts sort of look like a class in other languages. If you have seen those, once initialize this contract for the first time, the constructor will run and print out that line. Please make that line say whatever you want. All right, so we got this wave portal, which means that here we can go and say whoever works with JavaScript is a genius, especially the one who who are part of the Code with Ahsan community, right? We're gonna share this. We're gonna share the truth with the world. All right, so we got this, and let's see the next step. Submit the smart contract screenshot. Okay, I'm gonna quickly copy this, save this. So we have a smart contract now. We need to actually compile it, deploy it, and then the console log will run. So what we are going to do here is that we are going to go and make a file called run.js. So we need to go and create a file called run.js in the scripts. So I'm going to go there, scripts. I'm going to create a new file called run.js. Inside here, we got to put some code here. Let's quickly paste this and see what this does. So it essentially uses HRE. I don't know what that is. Maybe it's Red Hat Ether. Yeah, maybe that is what it is. And then ethers.get contract factory wave portal. Then we create a contract, wave contract factory dot deploy. Okay. Then we say wave contract dot deployed. Then we console.log, and pretty much about it. So that's what's happening here. How does it work? This will actually compile our contract to generate necessary files. We need to work contract under the artifacts directory. Go check it out after you run this. Then we have blah blah blah. So I'm going to run npx hardhat run scripts. So we are running this scripts slash run.js file. And so once this does it, you see we got the log that whoever works with JavaScript is a genius, especially the one who are part of the Code with Ahsan community. Yay! And then we have contract deployed to this particular link. So this is the address where our contract is deployed. We actually added this run.js. We looked at it. This when this file starts, it runs this function which goes inside, and then it runs the main function. The main function essentially creates a contract factory, and a factory is something that gives you something. For example, this is a class or this is a contract, right? This contract is just a class, and if you want an instance of the class, which means let's say human is a class, and now you want a person. For example, you want Ahsan. So Ahsan is a human, an instance. So if you want Ahsan, it's not the class itself, but it's an instance of that class. So when we use a factory, that essentially generates an instance of that class. So you can see here that we are creating a factory. Then we do this factory.deploy, which essentially should deploy an instance of this wave contract. That's why it is called contract. And then we have wave contract.deployed. When it's deployed, then we just show this message that we see here at the bottom of our screen. So this is what we did. One of the things that I was thinking, and they cleared it in the code, that where does this HRE come from? I don't see HRE anywhere. If I find it, it's just one of one. There is no mention of HRE. What is this HRE? And it's mentioned at the bottom here. This HRE is something that is created on the fly. So here it says, when you run npx hardhat, you are getting this HRE object built on the fly. So it's created dynamically using the hardhat config.js. So hardhat config.js, let's have a look at that. This is the file. So there should be an HRE file here. All right. So here it is HRE, which gets it somewhere from here, and then it runs it. So this means we will not have to do this ever. That's fine. You see HRE in Lord, but you never imported anywhere. Check out this cool hardhat documentation to learn more about it. Good. Go to the progress and put a screenshot of your terminal with the output. Be sure to make console log whatever you want. You have written your own contract and ran it deploying to the blockchain. Yay, let's go. So we're going to take a quick screenshot of what we have done so far. So here we took this screenshot. We're going to copy this. We're going to save this. And then we are also going to deploy this. I'm actually liking the experience so far. So I'm going to submit this. I'm going to also go into the progress channel. All right. Then we go to the next lesson. Let's see what that is. From here, let's add some fanciness to our contract. We want to be able to let someone wave at us and then store that wave. So in this particular situation, in this app that we are building, anyone on the internet with a blockchain wallet can come and say hi to us. That is the application from what I understand. So the blockchain, think of it as a cloud provider. It's like AWS, but it's owned by no one. So it runs using compute power by mining machines all over the world. Usually these people are called miners and we pay them to run our code. So here is updated contract we use to store the waves. So now we are adding a couple of things to our code. So I'm going to go to my welcome.solidity. Previously it was just a console log here, but now we are going to add a couple of things here. So I'm going to copy this console log and then replace their console log with it. I like to keep my code formatted. So I'm going to do that. And now we have it. All right, so let's see. So we got some functions in this contract. One is called waves. By default, we initiate this uint 250 blah blah blah. Let me actually see in the code. So we say two, we are getting an integer here or unsigned integer, total waves. Then we do a plus equals to 1. Then that's pretty much it. And then we just use this total waves whenever we want to return it. Okay, one of the things that I'm finding weird is where is this initialized, or is it initialized by default to 0? And here they answer that. And we also added total waves variable that automatically is initialized to 0. But this variable is special because this is called a state variable, and it's cool because it's stored permanently into the contract storage, which means that this variable is always going to be here. We also use some magic here with message sender. This wallet address of the person who called the function. Okay, this is awesome. It's like a built-in authentication. We know exactly who called the function because in order to even call a smart contract function, you need to connect a wallet. Exactly, as I said, in order to work with blockchain, you need to connect your wallet, Ethereum wallet or your blockchain wallet. In the future, we can write function that only certain wallet addresses can hit. Okay, like for admins and stuff. For example, we can function so that only our address is allowed to send a wave, or maybe have it where only our friends can wave you. Okay, so I think our code so far is good. Updating run.js to call our functions. So run.js needs to change. Why? Because we need to manually call the functions that we have created, of course. So now I'm going to update my code into the run.js method. So far we don't call these APIs from anywhere else, but just the run file itself. So when we deploy our code, we see these console logs, and then whatever we are running here gets run. So let's see what happens here. We run the main, it comes here, runs the main function, it gets the owner and the random person out of the ethers get signers. Okay, then it creates a portal, it deploys it, and then what happens is that this probably gets get total wave, so it gets the wave count using JavaScript, and then it does wave contract.wave, which is super simple. Then it does wave transaction, this is transaction.wait, so it waits for the transaction to complete, and then it says get total waves, and then we have the wave counts. Okay, but we are not logging it anywhere, right? So we have to log it in the end as well. How does it work? In order to deploy something to blockchain, we need to have a wallet address. Hardhead does it for our magically in the background. But here I grabbed the wallet address of the contract owner, which is owner, and also grabbed a random wallet address and called it random person. Cool. This will make more sense in a moment. Okay. So contract deployed by owner address. Are we logging this somewhere? Yes, we are. Then contract deployed to wave contract.address. All right, basically we need to manually call our function just like we would a normal API, and then script would normally run. Okay, so now if I do this, let's see what happens. And quickly go clear this terminal out, bring it up, run this. Let's see what happens. Compiling the file, compile finish successfully. So first of all, we got our log from our Solidity file in the constructor. Whoever works with JavaScript is a genius. All right, then we said contract deployed to this address. This address is on blockchain where this is deployed. Then contract deployed by this address, which is me, the owner. And then we have 0 total waves. Then we deployed this again. And then we have 1 total waves. Awesome. If I run this again, will there be 2 waves or not? Let's see. Because I think this is going to deploy a new contract. Yes, it's going to deploy a new contract. So because this time we would have the same address that we are deploying to, but a new contract. Cool. Now that we have got this, we can quickly share this screenshot as well, because I believe they're going to ask for it for sure. Now that we have this, we get the random person signer, then we deploy the contract, then we deploy this, then we have a wave count, and then we have wave transaction, and then we have wave count, get total waves, then we do contract.connect random person.wave. Okay, so the only change that we are doing is this. We are doing connect with random person and then waving, and that's pretty much it. So let's quickly go ahead and do this. So we are going to do it right here. Instead of just wave contract.wave, we need to say wave contract.connect random person and then wave. So that means we are going to get this random person. Are we also logging the person's name somewhere? This random person that we have, no, we are not doing anything apart from that. All right, so I'm going to quickly go and run this again. That means we are doing it using a random person. We got this guy, and then we got again, this has waved. Now see that here we had like 266, which was the owner. So the owner was waving so far. because we didn't connect this with anyone else. Notice the 2266 at the end. But now, since we have got a random person, we got 2266 here, but this person is now different. This is a random person. So someone else has waived now using this contract. Super cool. So I'm gonna quickly go ahead and now copy the screenshot as well. Let's do that and save this guy really quick and submit the quit feedback. So next lesson. Remember, when you run, it's actually creating a new local ether network, deploying your contract, and then script ends header will automatically destroy your local network. Yes. So that means that whenever we are running this command, you see we always have like one wave here. And this means that we are doing it every time. And now we are talking about deploying it in a way that it lives there forever and we can keep calling it somehow. So we need a way to keep the local network alive. Well, think about a local server. You want to keep it alive so you can keep talking to it. For example, we are going to do the same thing here. Head to a terminal and create a new window. All right, so here we need to create a new window. So we are going to go to our terminal, create a new window and run npx red hat node. Then you just started a local Ethereum network that stays alive. Super cool. And as you can see, Hard Hat gives us 20 accounts to work with and gave them all 10,000 Ethereum. We are now rich. Wow, best project ever. Awesome. So right now, this is just an empty blockchain, no blocks. We want to create a new block and get our smart contract on it. So under the scripts folder, create a file called deploy.js, and here's the code for it. Okay, so now we are going to create a new file called deploy.js inside scripts. All right, deploy.js, and then use that. And here are the 10 accounts that they talk about. So we started a new server at 8545. All right, these accounts and their private keys are publicly known. Any funds sent to them on mainnet and any other live network will be lost. Okay, cool, cool, cool. So we got 1000 Ethereum for all of these accounts. Cool, cool, cool. Awesome. So now we run and deploy this. So we got this deploy one, and then we need to run this command. So let's see what the command itself is. And this has to keep running. So this window needs to keep running. Do not close this one, but go to the other one and run this command npx hard hat run script deploy network localhost. There we go. So here we deployed this account, and I know now that this 2266 is my account. So here we deployed our network to localhost, and this means that what have we done? We have got the deployer, we have got the account balance, we are doing a contract factory wave portal. Then this wave portal is considering itself as a token. Here it was called contract. We call it contract factory, and then we call it deploy. Here we are calling it token and then token.deploy. Then we say portal.deployed and wait for that, and then we have portal address here, and that's pretty much it. So now when we run this, we see the portal address and whatnot. You need to make sure you do this from the my server portal directory. Exactly, we don't want to mess with the terminal window. Yes, yes, yes. Okay. Yes, yes, yes. So we deployed a contract, and we also have this address on blockchain. Our website is going to need this, so it knows where to look on the blockchain for your contract. So we need that address. Imagine if we had to search the whole blockchain for our contract, that would be bad. Yes. In your terminal window that's keeping your local Ethereum network alive, you see something new, which is this. All right, here we now got something else. So we already had the accounts, but now we have these like the deployment. So contract deployment, web portal, contract address, transaction, from, value 0 ether, gas use this, and then block number 1. So this is a block in, and then we also got the console log of constructor itself. Cool. So it only created it, but it didn't execute anything. Interesting. But what's gas? Before you click lesson, honestly, just give your pat on the back. You've done a lot. Next will be actually building the website that will interact with our local Ethereum network, and it's going to be awesome. Head to practice and let me know how this project going so far. I love your feedback. So we are going to close all of these windows, going to go and share the screenshot. Yeah, let's take that screenshot, and then we'll share that in the chat here as well. And then we'll save this as well. And then we are going to go ahead and this guy, submit, and let's see how this goes later on. All right, so lesson submitted. Oh, we have moved to section 2. Nice. This is cool. All right. So awesome. One of the things that I'm thinking about right now is we got some good progress here, and now we're jumping into the next go. All right, note you don't have use REPL to build it or deploy your site. If you want to use create React app, here's the link to the base repo you can clone and work on locally. Okay, we can also work on REPL. That's fine. Instead of having to set up a local environment, write commands to deploy It's all just given to us. Make an account on REPL it. Then you just go there and near the right you see the fork button. So we are going to create REPL Wave Portal Starter project. Going to fork this. I already have my account connected from there. Then please note as you go through this project, you may notice that we are referencing .js files in REPL it. If you're creating any new JavaScript files, you will need to use the JSX extension instead. REPL it had some performance fancies that requires you to use the JSX files extensions. Okay, so let's see this project now. So if I run this, it's going to run the app just like this. So if I do wave at me, that doesn't do anything for now. That's fine. And now I need to find a way to fix this. That's sad. Do I need to refresh? Will it fix it itself, please? Yeah, yes. All right, so here we just have on click wave, and then when you do on click, it doesn't do anything. Cool, cool, cool. So one of the things that we need to do is to set up our wallet, and that you need to do using MetaMask. I already have that working. So I already have some account here, and this is a test network, so don't worry about that. Maybe I can connect with my own local host as well. Here it is. So on my local host, I can connect with an account, and I should have that. All right, we need an Ethereum wallet, a bunch of these. There are a bunch of these, but for this project, we are going to use MetaMask. So we have our extension already set up. So this is my site. I'm gonna paste it there, and then we already have our MetaMask set up. So go ahead and close the terminal. Your local blockchain network is running, which is where you ran npx threaded node. We won't need it anymore. Okay. Now we are going to be doing the real deal, deploying to actual blockchain. Okay. Go ahead and make an account with Alchemy here. All right. So I'm going to create an account for that. Sorry for having you make so many accounts, but this ecosystem is complex and we want to take advantage of the awesome tools out there. What Alchemy does is gives us a simple way of deploying to real Ethereum blockchain. Alrighty. So what did I do? Most popular is this one. Then we have crypto. Ethereum is a great default choice. Yeah, we are going to use Ethereum. Create your first application with Ahsan, and then we got Wave Portal. Then we create the app. Then we say free one. All right, so the Alchemy account is created now, and we've got some links and whatnot, a dashboard as well. So now let's continue. So we created the Alchemy page now. So when we want to perform transaction on Ethereum blockchain, we call it a transaction. For example, sending someone Ethereum is a transaction. Doing something that updates a variable in our contract is also considered a transaction. So when we call wave, it does do this. Total waves plus equals to 1. That's a transaction. Deploying a smart contract is also a transaction. Remember, the blockchain has no owner. It's just a bunch of computers around the world run by miners that have a copy of blockchain. When we deploy our contract, we need to tell all those miners, hey, this is a new smart contract. Please add my smart contract to the blockchain and tell everyone else about it as well. All right, this is where Alchemy comes in. Alchemy essentially helps us broadcast our contract creation transactions so that it can be picked up by miners as quickly as possible. Once the transaction is mined, it is then broadcasted to the blockchain as a legit transaction. From there, everyone updates their copy of blockchain. This is complicated, and don't worry if you don't fully understand it. As you write more code and actually build this app, it will naturally make more sense. All right, so we created an account with Alchemy. Check out the video to see how to get your API for a testnet. All right, so that means our application should be on Rinkyby. So we're gonna go to our web portal, and instead of mainnet, we need to update it to Rinkyby. Can we change that? Yeah, edit app. Here we got Rinkyby, and then we hit save. And now there we go. All right, what else? So we go here and then we click the view key, copy HTTP here, and then we use that into Hornet. All right, we are not going to be deploying Ethereum mainnet until we are at the very end. Why? Because it costs real money and it's not worth messing up. We're going to start with the testnet, which is a clone of mainnet, but uses fake dollars so we can test stuff out as much as we want. But it's important to know that testnets are run by actual miners and mimic real world scenarios. Okay, this is awesome because we can test our application in real world scenario where we are actually going to broadcast a transaction, wait for it to be picked up by actual miners, wait for it to be mined, wait for it to be broadcasted back to the blockchain, telling all other miners to update their copies. So we'll be doing all in this with a few lessons. Cool. So here, in order to deploy to Ringyby, we need fake ether. That's because if you're deploying to actual Ethereum mainnet, you would use real money. So testnets copy how mainnet works. Only difference is no real money is involved. In order to get fake Ethereum, you have to ask network for some. This fake Ethereum will only work on this specific Testnet. You can grab some fake ethers for Rinkybuy through a faucet. Make sure that your MetaMask wallet is set to Rinkybuy Test Network before using faucet. And then for my crypto, you'll need to connect your wallet, make an account, and then click the same link to request funds for official Rinkybuy faucet. If it is zero peers, not worth the time to make tweet public post. Okay. So here we got build space that has some Ethereums like 0.25. Having trouble getting testnet Ethereums? I already have those. So for Rinky Buy, what you usually do is that you go there and then you select, hey, how many ethers do I want? And then you get those ethers after doing a tweet. So you need to either tweet or share this on your Facebook with your Ethereum address. And when you tweet, you link your tweet here and then you ask for the ethers and then they send it to you. Once you have those, you should be able to see it's something like this. So I'm on localhost right now. Instead, I'm going to go to Rinkybuy test Ethernet and you see that I got 0.1 ethers here. So that's fine. That's good. Let's see. If the above doesn't work, use the faucet command in the faucet request channel and our bot will send you some. If you want some more, send your public wallet address and drop a funny GIF. Either me or someone project will send you some fake ethers as soon as they can. The funnier the GIF, the faster you will get fake ether sent. Lol. So we need to change our hardhead config.js file. You can find this here into a smart contract project. So I'm going to quickly go there and change it into the code. And before I do that, let's see what we changed. We have Rinkybuy, URL, Alchemy URL, and then account key. So first of all, we are deploying our code to the blockchain. And when we say the blockchain, we are talking about the test network called Rinkybuy. So we already followed that. We copied the API key. I'm going to quickly do that again if I did not. So I'm going to copy this API key. And now we are going to get some fake Ethereum. I already have Ethereum. For this, we are using something called a wallet. So when you go to the blockchain, you need a wallet. You need an authorization or an account. Just like when we open an application, we need to log in via Facebook, log in via Google, or in blockchain, we need to log in via our own account or wallet. So I have an account right now and I can select which network I'm connecting to. So you can see here that we have this Ethereum mainnet. This is the actual internet or actual Ethereum network or blockchain. I'm not going to use that. We are going to use this test network called Rinkybuy test network. And here you can also see that we got this Rinkybuy server here. Now that we have this, we just need to set up these values. So I will need to change my file and then I need to provide these values like the API, URL, and the account key. I don't need to commit this file to GitHub. Obviously, it has my private key. You will get hacked, robbed. This private key is the same as your mainnet private key. We'll talk about env variables later and how to keep this stuff secret. You can grab your API call from Alchemy dashboard and paste that. Then you need your private Rinkybuy key, not your public address. So first of all, I think we need to do this. So I'm gonna quickly go ahead and see. I'm gonna quickly put those values in. Let's see if we can get this to work. So we did something and then we are going to run this command to run this and deploy this to, you need to click here and then go to account and then go here and then click account details and here then you click export private key and you will get the private key. Then you need to open your code and then you need to add that to this file hardhead.config.js. Once you are done with that, this should be finally do it. And we got a lot of balance in our Ethernet account because it's a test account. All right, so we deployed this, that means, and now I can take a screenshot for this because I'm pretty sure they're going to ask me for that. So I'm going to quickly copy this, save this. Let's see what we have next. Yes, so it deployed the contract and then we got wave portal address as well. Good, good, good. So my contract is on. You can actually take that address and paste into Etherscan here. Okay. So I'm gonna now go ahead and on the Ethernet scan, I can check my address. So wave portal address is this one. Okay. So I'm gonna go and paste this here and it says there's no address there. Or is that, or am I supposed to get my address? Copy the address of the deployed contract in the last line and save it somewhere. Don't lose it. You will need it for front end later. Yours will be different from mine. Yep, that's the address, right? And or did I? No. Yeah, this should be the address. And I'm gonna stop this server. No need. So this is the web portal address. We're gonna save that into Notepad. There we go. And they said that you can go ahead and copy the Ethernet address. Okay, so we got the address. My bad. We got the address. We don't have my name tag available here. There are no transactions there. And if I open it, what do I see? Contract creation. Okay. So the contract was created in this case. Good, good, good. And this is my account's ID. 0x46 blah blah blah. Yeah, there you see 0x446, and then at the end it's like 831D. Cool. Okay. Cool, cool, cool. So I think we are going in the right direction. Good. Whoa, you did a lot. Okay, yes. You should actually tweet that you just wrote and deployed a first contract and tag build space if you want a screenshot of either scan page. It's a big deal you got this far. You can deploy something into actual blockchain. Link your Etherscan page. Okay, where is my Etherscan page? Is that the one? Yes, that's the one. That's the one. Let's see. This is good. This is fun. So now that means, so in order for your website to talk to blockchain, we need to somehow connect our wallet to it. Once we connect our wallet to a website, our website will have permissions to call smart contracts on our behalf. Remember, it's just like authenticating to a website. Okay, head over to Replit and go to app.js, and under source, this is where we will be doing all of our work. So inside app.js, that's where we are going to work on everything. Cool, cool, cool. So if you're logged into MetaMask, it will all automatically inject a special object named Ethereum into our window. Let's check if we have Dust first. So I'm gonna copy all of this code, go to my app.jsx, paste it there, and see what happens. Save this. Okay. So here, can I go to console and check window.ethereum? No, this is the console shell that's running. It's not running the console of the app itself. That should be here. So we do window.ethereum. All right, so here we got window.ethereum, delete property, blah, blah, blah. So when you run this, you should see the line, we have the Ethereum object printed in the console of the website when you inspect it. If you are using REPL, make sure you're looking at the console of the project website, not the Replit works, where you can access the console of your website by opening its own window tab and launching developer tools. The real should look something like this. Yeah. So if I go and do this, sort of. So here it said we have the Ethereum object. This is the log that they are talking about. Cool, cool, cool. Alrighty, let's see. So next we need to actually check if we are authorized to actually access the user's wallet. Once we have access to this, we can call our smart contract. Basically, MetaMask doesn't just give our wallet credentials to every website we go. It only gives to websites we authorize. That makes sense? It's just like logging in, but what are we doing here is checking if we are logged in. So check the code below. So here it says check if wallet is connected. So it takes Ethereum, then it checks if not Ethereum, then we have an error and we don't have MetaMask in that case. Otherwise, we got the Ethereum object. Then we do Ethereum.request method Ethernet accounts. So we get an account here. Then we take the first account and then we say find an authorized account. And then we set the current account to the account. What happens then? Then we show this message. Okay. So it's a really simple thing that's happening here. Cool, cool, cool. Let's do that. I'm gonna save this. So now it says no authorized account found, right? You see the message here? Do you see the message here? So we got no authorized account found, and that happens when we get accounts.length, then we say found authorized account, otherwise no account. So that means, and when we say ethereum.request Ethereum accounts, it only sends back the authorized accounts. So that's good. Build a connect wallet button, which means that we are now gonna ask for connection and authorization. So let's do that. When you run above code, the console log that prints out should be no authorized account found. Yes, because there's no authorized account yet. When you create a connect wallet button in the world of Web3, connecting your wallet is literally a login button for your user. Yes. So here now we are going to start saying check if wallet is connected is the same, but the connect wallet is the second method. So we say Ethereum, alert get MetaMask, return. Otherwise, we have Ethereum request accounts. That is the method. Here we got Ethereum accounts, but here we have request accounts. If we say connected, then it's good. Otherwise, it's going to say a console log error. All right, so we are going to say connect wallet. Cool, it opened MetaMask for us. It is asking for connecting. So we have this address here. Then we say select accounts. We say next here. And all it requires is view addresses of your permitted accounts required. Okay. When we connect with this, we say connected. Woo! We are making progress. Our code is getting a little long here, but you can see how short our connect wallet function is. In this case, we use the Ethereum request account function because we are literally asking access to the user wallets on line 69. We also added a button. I don't know where the line 69 is, but I trust him. Alright, now it's time for our magic. Check out the video below. Required before you click the next lesson. We just a lot question. Be sure to ask section to help. What does it mean to learn alongside other for you? So All right, so our smart contract has this function that retrieves total number of waves. Yeah, we already know that. Let's call this function from our website. Yay! Go ahead and write this function right under connect wallet function. So I'm gonna copy this, go to our code, and then no, that's not the code. It should be repl it. So here now I can go ahead and say the wave function here. The wave function gets Ethereum, then it says Web3 provider Ethereum, then it gets the provider, then it gets the signer, then it gets the wave portal contract using the contract address. Okay. Then it has contract ABI signer, and then it gets the total wave just like this. It converts it to number, and that's it. Now the thing is, where is this contract address coming from? We probably have to add that, right? Somehow. So, quick explanation here. Yes, so ethers is a library that helps our front end talk to our contract. Be sure to import it top using import ethers from ethers. Okay, I think we're doing it. We're not doing it. So import ether from ethers. There should be a package for this one as well. Yeah, there you go. Ethers. So we have a package in the package JSON ethers. That's what we are using. All right, cool. Then provider is what we use to actually talk to Ethereum nodes. Remember how we were using Alchemy to deploy? In that case, we use nodes that MetaMask provides in the background to send and receive data from our deployed contract. All right, then we got a wave button. Then, so right now the code breaks. Our REPL says contract address is not defined. Yeah, I haven't even run it because of the same reason. So there should be these errors. We need to provide these two variables. So the contract address you have, right? Exactly, yes, I have. But what is an ABI? Much earlier in I mentioned how when you compile contract, it creates a bunch of files for you under artifacts, and ABI is one of those files. Remember when you deployed your contract to Rinkebit test, the output of that deployment included your smart contract address, which should look like something like this. You need to get access to this in your React app. So we need to have sort of a contract variable here. So I'm going to create that. I'm going to go to REPL it, and just below the contract, or where we are supposed to use this contract address variable, we're going to create it right here. Then let's open the notepad. Yeah, that's my address. So I'm going to quickly go and paste that. Now the second thing was ABI. Get the ABI file content. So it's something like contents of the API can be found in the fancy JSON file in a hardened project, artifacts, contracts, wave portal sol, wave portal JSON. So we're going to go to our artifacts, contracts, welcome.sol, JSON, and ABI is here. So we have this ABI. So that means we're going to have this whole ABI. It's like an API, application blockchain interface, bytecode, blah, blah, blah. So how do we get this JSON from into your front end? For this project, we are going to just go to copy pasta, copy the contents of your web portal JSON, then head to your web app. You're going to make a new folder called utils, and then we create that JSON file. So the full path would look like blah blah blah, and then press the whole JSON. So the ABI is not just the ABI itself, but the whole thing here. All right, so we're gonna go ahead and create that into source. Was it utils.js? New folder called utils, and I'm gonna create a new folder called utils, and inside here we're going to have a new file called waveportal.json, and then in this file we're going to create all that, right? So we got that now. Okay, what's next? And then we need to do, after the copy pasta, we need this as well. Contract ABI equals to ABI.API, and we also need to import that up top. So we're gonna go ahead and into our REPL it, we are going to go to our JSX, import the ABI from utils.waveportal.json, and then here we need to just say const contract ABI ABI.API. So we go into our wave file and do this. I'm gonna also try to take a look at where you are actually using this ABI. So we got provider, signer, wave portal contract, blah blah blah. Once you add that file and click the wave button, you'll be officially reading data from your contract on the blockchain through your web client. Okay, writing data. So if I go ahead and say wave, this should console log the value of the wave right here. So if I click wave at me, would it give me back the data or no? So we're gonna go and say custom levels, errors, extension in invalidated. Something is definitely wrong here. So we got contract ABI here that is being used. We got contract address here that is being used. We got the wave button here. Oh, we're not calling the function here. So wave should be called here wave, right? And I save this guy. I refresh this and click this. And there you go. Retrieve total wave count. Woo! we are now retrieving our wave count, which means that now we can start talking about writing those to the blockchain. So let's add the new one. Writing data, exactly different. When we want to write new data to client, we need to notify the miner so the transaction can be mined. When we read data, we don't need to do this. Reads are free because we are doing is reading from the blockchain. We're not changing it. Here's the code to wave. Okay. So we got Ethereum here. We are getting wave portal contract. We get total waves, console logged. Then we execute the actual wave from our smart contract, which is this guy here. Then it says mining. Then it says mined. And then we got get total waves into this. So I'm gonna quickly copy this, go to our REPL right here, and then we do this. All right, so we got this, save this, and now we are going to write one, and that would make our count go from 0 to 1. Okay, so it's opening my MetaMask for transaction. New address detected. Click here to add to your address book. Okay, we are calling the wave function here. As you can see, the details contain this amount of Ethereum for this call. Then we got data that we are sending. Okay, insights not supported. That's fine. Okay, so if we say confirm, that says mining now, and then it would potentially say mined, and then the log. So I got a notification actually. Oh, I cannot show you that. Can I do this? Can I do that? So you see mined here and retrieve total view count or wave count is 1, right? So on Etherscan, we got our transaction. This is the transaction that we just created. This is the notification that I got. So I got from MetaMask one transaction confirmed, view on Etherscan. I clicked it and there we go. We got a transaction hash, and from this account, this is my account, and this is probably the Wave contract account, which is 612A. Is that the Wave contract account? Yeah, 612A. That is the smart contract account. And the other one is mine. This makes sense. What's awesome here is that while transaction B is being mined, you can actually print out the transaction hash, copy paste it to Etherscan, and see it's still being processed in real time. Didn't we just do that? Yeah, we did, which is this. So this is right now being mined. Indexing is the status. When we run this, you'll see total wave count increase by 1. You'll also see that MetaMask pops and asks us to pay gas, which we pay for using our fake transaction. And there is what gas essentially is. I'm going to look at that later on. So now we have actual client that can read and write data to blockchain. From here, you can do whatever you want. You have the basics down. You can build a decentralized version of Twitter. You can build a way for people to post their favorite memes and allow people to tip the people who post the best memes with Ethereum. You can build a decentralized voting system that a country can use to vote in a politician where everything is open and clear. The possibilities are endless, yes. Customize your site a little to show the total number of waves, maybe show a loading bar when the wave is being mined, whatever you want. Do something a little different. Once you feel like you're ready, share the link to your website with progress so we can connect our wallets and wave at you. You're on your way to conquering the decentralized web. Impressive. Take a look at the code. What did I do? In this link by visiting this link to make sure you're on track with our code. Okay. We could enhance the UI a bit. I'm not really sure if I want to, but we could do it. But do you think we should be improving the UI of the app? Do we want to do React, or do we want to quickly get into the next steps? We can just say the world a better place using software. All right, we can take a screenshot of this one, save this, and then just submit it. Yay, we got to section 3 now. Storing messages in arrays using structs. That's where we want to be. We want to make our application a bit dynamic, so we want to store messages. That's cool. At the end of the lessons, we want to let users submit a message along their wave, have the data saved somehow on the blockchain, show that data on a site so anyone can come to see all the people who have wave data and their messages. This actually makes me think. We started an application called helpme.io, and the idea for this application was have a way of saying that, hey, this person helped me with something. Is that something that could be taken to blockchain? Because the problem with the current implementation was we needed to have a way of GitHub URL or something like that. But then I was thinking, hey, what if this person, let's say I helped someone and they want to that Ahsan help me out, how would they mention me? Would they mention my Twitter? Would they mention my GitHub? What would they mention? But if we talk about Web 3.0, they can just mention my address. So now we have total waves. So looking at the code again, this is exactly the same as before. So it's a number of total waves done by someone to me. So it's going to be the total count here. Then we got a new wave that has address index from the timestamp and the message. Cool. Then we got a struct here which has address, string, and timestamp. So these two signatures are quite the same. Then we got an array of waves where all of the waves are going to be saved. Interesting. Then when we do a wave, we increase the count. Then we do waves.push, and then we create a new constructor of wave itself, which is this, or using the struct itself. Then we have message sender, message, and book timestamp. And then we emit a new event called message sender, timestamp, and the message. So whenever we change our contract, we want to change run.js to test the new functionality we added. That's how we know it's working how we want it. Here's what mine looks like now. So we still get the contract, we still deploy it. We have the wave count here, get the total waves. We create a transaction using a message. It waits for the message, we get a random person, connect it, sends another message, we wait it, all the waves, alrighty. So I'm gonna copy this. Here's when I get my terminal when I use npx run.js. Yeah, that doesn't run it on Ethereum, that only would run it on my local machine, I believe. Oh, this will actually deploy this, but where? I'm a smart contract, player of the game, contract addy, 0 total waves, then we send a message once, twice, and there we go. In the end, we could also get the transaction count. Like do this again, just to see that we got 2 transactions. So I'm gonna save this, I'm gonna run this, and let's see. Yeah, there we go. We got total of 2 waves, count 2. Awesome. Alrighty. The array looks scary, but we can see the data next to words, waiver, message, and timestamp property. So we got a message here, we got a big number here, waiver, message, timestamp. Okay. So we need to deploy again. We need to update the contract address on our front end. We need to update the ABI file on our front end. People constantly forget these 3 things. Okay. Alright. So that means, from what I understand, is whenever we deploy or do a change to our code, we have to redeploy, and we have, that means the old contract still exists in the blockchain, because from what I understand, you cannot remove things from there as far as I know, but I might be wrong. I don't know, but at least for every deployment there is a new contract deployed, and we need to use that address, that contract's address. As they say, the smart contracts are immutable. They cannot change. They are permanent. That means changing a contract requires full redeploy. This will also reset all the variables, since it would be treated as a brand new contract. That means we would lose all our wave data if we wanted to update the contract's code. If we do a reload and if we want to get the original data, then we can just use the old app's address or old contract's address and assign the new contracts from there, right? So what you'll need to do is do this npx blah 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 rinky by. Let's quickly do that. Okay, so this deployed it there, and now we have a new address. So we copy this, go to our app, update the contract address, save it, and now we've got an authorized account. One of the things that is interesting to me is the address is different now, but still my account is authorized. Is this because previously it was also authorized into the previous app? We want to redeploy our code as we discussed. We created our own version of it. So we did run npx. So if I run this now again, it will give me a new address, I think 951b. And see, my balance is changing every time. Whenever I deploy, it takes some amount out of my Ethereum account, because this is a transaction as well. So that means they are charging for every deployment, which makes sense. And now we have, look at this, a different address. So in my REPL, where we have the current account and contract address, we need to do this. So we need to first add this all waves thingy, then we need to add contract address, take out the contract address from this file because we have that mentioned up top now. Then we got get all waves. So we need this method now, get all waves. So we got that. Let's see what it does now. Let's see, get all waves gets Ethereum, gets the Web3 provider, then it gets the signer, then it provides it gets the web portal contract. So it gets our smart contract from the contract address. Then it runs get all waves, which should essentially run our Solidity code. So the get all waves function in our web welcome.sol, there is this get all waves method, which essentially just returns the waves. And then that's what it does, it just returns back those. I need to understand what these memory and public view returns, blah blah blah. The syntax, I'm not really familiar. It's the second day, of course, but I'm gonna have to look into that later on if I have to build something really. So we got wave clean, waves for each, then we got wave clean dot push. So we get waves, then we get a for each, then we do a wave clean dot push, and then we get the waiver, the timestamp, and then we get the message. Okay, and then we just set all waves. That's all about it. Okay. Where do we call this brand new get all waves function though? Well, we want to call it when we know for sure user has connected the wallet with authorized account. We need an authorized account to call it. Obviously, hint, you have to call this function somewhere in the check if wallet is connected. I'll leave it to you for figuring out, of course. So we got all get all waves. If we get the account connected, then we need to call the get all waves. That should be it. All right. Then we also need to update the UI to have those waves, right? There we go. We got all waves here. Go here and just below the button itself, header, bio, wave at me, and then we got this guy here. All right, so we don't have any waves so far. So, wave is broken. Basically, just go through all waves and create new waves for every blah blah. So wave function no longer works. As we try to wave, it just gives an error because it's expecting a message to be sent now. So if I click wave, they mean that it's going to be broken. So we're going to quickly check it out. So wave at me. It's going to go and click confirm. So it's mining now. All the activity will be recorded on the blockchain. Okay. All right. So our wave function is not broken at all. I called the wave function. The wave function worked. Why did it work? And why do I have all these counts? 378. What the heck? All right. Wait a second. What just happened? This is the contract address. That is the latest address, right? So I'm going to confirm that I'm using this. Oh, because I'm using probably his. That's why. There you go. Cannot estimate gas, transaction may fail or require manual gas limit, blah, blah, blah. Now our code is broken. So we need to pass a message from here, or actually not from here, but when we do a wave, get total waves, and then we got this guy here. So wave transaction, this is a message. Let's say CWA community, and then we save this, and then we are going to run this. Too many arguments passed to contract, count equals to 1, expected equals to 0. Okay. Oh no, we also need to build the ABI, right? So we did miss one thing, that is in the artifacts we have a portal.json here. So we need to copy this portal.json, go into our code, go to utils, go here, save this file, go back. So I'm going to open JSX and we're going to run this again. Wave, let's go. This is working now. So we are confirming this, it's going to mine this, and then we are going to be able to see those messages. Woohoo! Let's see. So we got the message now, but guess what? Our waves or our UI didn't show the new number of messages. Why didn't it show? Because we don't have the code written. We haven't written that, hey, once you wave, you get the new messages. We only do that when we refresh. So if I'm going to refresh this, it's going to probably get the messages and we should be able to get messages. So we got get all waves. Is it defined? Yeah, it gets it. Then it tries to get the Ethereum, gets the data, assigns it. And the question is, am I console.log? So it's not reaching my code for sure. It says found an account, but then it doesn't call it. Have I put it into the wrong place? It says connected, right? Oh, it's big sad. I should have done it here. Set current account equals to account. That's where it should be. So here it says contract ABI is not defined. Why does it say so? Because contract ABI is not defined. Yes. Let me quickly see. I have messed up the code a bit. So I need to see where I did that. Contract ABI. I removed contract ABI somehow. Yeah, here it is. Contract ABI equals to ABI.ABI. So I need to put that up top. It should be here. Now I can remove this from here and I think we should be good. So we got the message CW community, which means that we can add more messages and get more messages out of it. One thing that we know for sure is when we add a new message, we need to call this get all waves again, right? We need to do that. All right, so one thing that I was saying, that there is this method that we call when open the application or when we refresh the application. This essentially gets us the messages, but when we have a new message that we want to send, we definitely want to do this again. So we got this method called wave, which sends a message. So once we have done everything, once the transaction is over, we should also call this method again here. So we send a new message and then we also retrieve the newest messages and then show them here. So I think what we need to do is go build a UI, go make these things look good. However you want to look at, won't be teaching you much of that here. Feel free to ask questions in section 3 help. We got a good base here. Let's add some things to it. Let's add some cool UI to it. Alrighty, I was talking about the UI itself. Do we have an index.html? Yes, we do. So we're gonna add a cool little font that I personally love, and you're gonna probably see a lot of my apps actually. It's definitely in the Flashback app, appflashback.com. It's definitely here, this font. I absolutely love this font. It's called Dongle. So I'm gonna copy this Dongle font into the wave. So we're gonna add this link here, and then we are going to add the CSS here to make our code really nice. We're gonna quickly go ahead and add a style tag. There are so many things here. I'm just gonna add the dongle one here. There we go. You see the nice UI now? We're gonna have to increase the font size, to be honest. So let's say font size becomes 24 pixel. So we got hey there, and then we also see some couple of things here and there. Do we have a fixed size here? It's a div class name header. This header is styled somehow. Here you see it has a font size of 32 pixel. That's why it didn't grow up. We can make this a header or a heading per se. Instead of giving that, maybe use a h1. So let's have a quick look at if there is any margin to this. Yes, we have a margin here. So we're not gonna have any sort of margin, which we have probably in the, yeah, let's say margin 4 pixel 0. So not too much margin. Yeah, this is much better. Then we got this guy here, which also has some sort of margin that I don't really like. It's bio. Oh, I saw that. I saw that. Margin top 16 pixel now. Not 16, maybe 8. More than enough. Let's make the messages a bit cooler, right? I really love the color purple. All right, 99, 201, and 241. That's the color. So I'm going to quickly go and set that to the heading, to the header. We got color and RGB. All right. So we got that. All right. And I can also have my bio link there, so we can have people connecting to me. So let's say maybe we can add just the Twitter Ahsan or a tref https twitter.com/code_with_Ahsan. So we got Ahsan here, we got the link here as well. We're gonna make this our target as well. Target blank, and then we have a rel equals no opener, no referrer, and I think we should be good. Cool. So we were looking at the wave at me stuff. So what we are going to do is first we are going to update this button and the input, and then we can quickly go. I mean, we could also just add sort of a the tailwind CSS. I mean, I could do it, but let's see. So we got the wave at me, we got the messages here. Let's add the same color to the messages background. So we are going to have this message. I'm gonna give this a class, background color overlays. I'm gonna give this a class, or actually just copy the color from here. So we're going to copy the color here, go and paste it here. But then we also need to give this a color of text white. So we say color white, and we should be good. We're gonna also get some other things like, let's actually get this an object. So we can say something like wave message styles, something like this. So cons wave message box styles, and then we got this. Let me save this guy. Can I format these? Control F. No, Control Shift P, format document, and there we go. And now we can add a couple of other things as well. For example, I would say a border radius is going to be like 14 pixel, like this, and we can also have some sort of styles to the container. So main container, let's actually add the styles inside this file. So we got margin top, but we also would have margin left, sort of 40 pixel, I don't know, pixel, not 40 pixel, actually 20 pixel maybe, or 10 pixel or 20 pixel. And margin right to be 20 pixel as well. So we get this like in the center. Width is 100%. That's not going to be 100% then. Otherwise it would, if we give width 100%, then we get a scroll. We don't want to scroll. So width is not going to be 100%. Wave at me. What else do we need to do? We got the wave at me message, but we could have something like write a message to me and something like that. So we got this button. Let's wrap this up inside a div. Then we can get an input here. Then we get a button here, right? Background color, blah, blah, blah. Did I mess something up? So this is okay so far. If I go and change this to a div, is it okay? Yes. If I add the button here, is it okay? Yes, it is. Then if I add an input here, is that okay? It is. Then I say this input is going to be having classes. So we can say ID, message input, and then we got some styles from there. So we can say, can we copy the styles somehow? Copy outer HTML. styles. There we go. And then we go here and then we say message input should have the same styles. So message input should have the same styles. There we go. So we got some padding is as well. You see at the padding at the left, we don't want that. So we're gonna be saying padding left is gonna go away. Actually have at least some padding, maybe a 0.5 rem, right? This is good. The font size here should be a bit bigger. Where do we have the font size? So it's 0.8 rem, maybe have like 1.25 rem, 1.25 rem. There you go. Looks good to me. Then we got the button itself. The button itself should go towards the right side. So I'm gonna actually have some styles here. Style, or we could say input container, give this an ID, input container, right? Let's give it that. Go to app CSS, add some styles here, display flags, flags direction, column, then align items, flags end, right? This is what I wanted. So we got this, wave at me, we write something, we hit wave at me, and that's pretty much it. Then this input container could also have a margin of bottom to just have a couple of spacing from the messages itself. And then we can also have sort of a heading that says messages. So go to app.jsx, just above the all waves, we could have an h3 that says messages, right? Something like this. Margin bottom should be 0 or something. I don't know, because there seems like a lot of margin below this word messages. Margin bottom should be 0. Yeah, it looks much better. So we got messages here. One thing that you need to notice at the very bottom is that we got no space. If I scroll all the way down, we got no space at all. So this main container should essentially have some sort of padding bottom. So app CSS main container should have padding bottom of like 30 pixel, and then we should be able to kind of have some spacing at the bottom. You see now we got some white space here. So yeah, simple and necessary UI tricks right there. Maybe we should have like margin bottom of, I don't know, input container 20 pixel. Give it a bit lesser margin. It looks like it has too much gap somehow. All right, now we got the messages. We can have our own in the app JSX. Do we have a margin bottom here as well? If we add more messages, it's gonna just go down. So it should also have a no, it has a margin top, so that's fine. Okay, cool, awesome. So we created some good UI here. We can now add a message here, use that, and then send it so we can see it as well. So let's implement the functionality of getting the input and sending it. So what we do here is that we create a new state variable. So I'm gonna say this is going to be message, set message, and then what we'll do is whenever we have a change in the message, we are going to propagate that there. So here we say on change, get e here, and then we do this. So we say something like set message e dot target dot value. So we set that to our message here, and then when we run it, or when we say hey send wave, we check if message doesn't exist. Then we say alert, please write a message, do a return from here. Let's save this and try this out. So if I hit wave me, it says please write a message. Cool. If I enter something, then it's going to send the message. So instead of this hard-coded message where we say CWA community, we're going to use the message itself and send it. Once everything is done, we need to send the message to empty. So we are going to do something like set message to empty string. All right, we got the code for sending messages. Let's try this out. If there's nothing, they say send a message. If I add a new thing, let's say hello from restarted. So when we do wave at me, let's see what happens. It's asking me for a transaction and confirmation. It's gonna ask for confirmation. So now it's in the state of mining. So it's kind of doing that right now. And I believe once it's done, we should see the message. Yay, let's go. You see here, we got the message. Now the UI isn't great because only I know and now you know that it was working in the background. Although we could have made this a bit better. First of all, we should have some sort of a loader that we can use here. What we can do is let's add sort of a loader from actually one of the loaders that I've built, pure CSS loaders. Let's get a loader from this one. Which one do we want? We go to our pure CSS loader, we paste the code here, and there we go, we got this. Now we're going to copy this and then make it a component real quick. We're going to make this a React component. Let's say we create a new file. Inside there, we call this loader.loader.jsx. and then we have this HTML here, and then we have also a new file that we call loader.css. Then we go ahead and copy the CSS, quickly go here, paste the CSS, and then we can add our file. Or actually, we need to import the CSS. So this should be a JSX. We're going to say const loader equals, and then return this. And also we need to import the CSS. So loader.css. And then we need to just use this into our app JSX. So I'm going to add this right below the heart, call it loader, and then import this from loader. So import, and we have not exported it, so we need to export that as well. Export default, and then here we can simply go ahead and say import loader. Should it be working? I think so, unless I've made a terrible mistake. Yeah, because I've not imported React in loader JSX. Please import it. There we go. So we are going to say loader here, and then we are going to have sort of something like width max content, and then margin auto. And I'm doing this because I want the loader to be centered on the screen. So I'm going to quickly go ahead and say in the app JSX, or we could actually have margin 10 pixel auto. So in the app JSX, we are going to wrap our loader inside this loader class element. Quickly go here, say loader. No, it doesn't do that here. Div class name loader, and then div, and then go ahead and paste loader. And there we go. We got it centered. Super cool. So once this is going to be maybe called transaction in progress, because this heart doesn't actually say that this is in progress, you know? So maybe do something like this, kind of wrap it around in a div, wrap this around in a div as well. So transaction in progress, this is going to be loader. This loader is also going to have sort of a display flex direction column, align items center. That means we just need to show the loader when the transaction is in progress. So let's quickly add a state for the loading state. And I think we should be good then. What I'm thinking is instead of this input and wave me, we are going to show the heart. That's what I think. And I'm probably going to be using llama's name for the transaction now. So first of all, let's add the state or the React state for this. So const is loading, set is loading with a capital L for loading, and then we got a use state, and then it's going to be false by default. Then we are going to set it, or we're going to use set is loading when we initiate the transaction. So it's going to say something like this, or not here actually, when it's an ethereum, then when we start this. So we start with setting the is loading to true, then at the end we go ahead and we set is loading to false, and then also we also set this? No. And if there's an error, then we also need to set this to false or hide the loader per se. What else is remaining? Yeah, there is a loading thing. So we got this input container, and we are going to say not is loading. Then we show this. Otherwise, we show here's the loader. And now I'm going to format this. Format document, please. All right, so now we don't see anything. So I'm going to say, hey, from llama knives. So if I do wave at me, there we go. Transaction in progress. If I cancel the transaction, it should still hide the loader. It's obviously important part of the user experience. You see, it hides the loader, sets it back to blank and whatnot. So I can do this again now with a success case. So hey, from llama knives, wave at that. Now it's asking me for confirming this. I'm gonna go and confirm this. And the transaction is still in progress because it's now sending the message to all the miners. Mine this transaction or kind of reflect back on it. And when they do, then this should hide again. Yay! Let's go. So we got the new message, and now this will stay there in the blockchain forever. And we got it. And we got a good UI to show. How about that? The only sad thing about this is that I cannot open this into a new page, and that absolutely sucks. I need to show this. Wave at me. There you go. So I'm gonna do a transaction here, confirm it, and now we got that here. Super cool. So now once the transaction is done, we should be able to see, yay, there we go, and we got the message here. Awesome, awesome. Let's save this. All right, let me quickly go and submit this. Submit screenshot. I think we have finished the section 3. That's what I think. Maybe not. Send Ethereum to people waving at you. Ooh, this is nice. This is going to be fun. So we're going to be looking into finalizing this. I'm at least trying to finish the section 3. So we're going to be finalizing this, and we're going to be then wrapping up. All right, so now that we have this, let's finally add the ability to send Ethereum to the people who are going to be waving at me. Now, what you could do is you could create an account on MetaMask. So you can go and create, let's suppose, a MetaMask account. Then that actually can be your first step of learning or getting into blockchain or Web 3.0. The MetaMask network, in MetaMask, you can select the test network. So we are not running everything in the main Ethereum network because that requires money. The Rinkibai test network has some here where you can have some Ethereums and then you can use them. So I am using the test network and you can see my transactions here going on. All right. So now that we have this, and when you do so, you can go to probably my application. I don't know if it's going to work because I don't seem to be having this working, but maybe I can send my REPL and you can probably click it from there. Anyways, in any case, let's send Ethereum to people waving at you, which means if you are going to wave at me, you're going to get some money. For example, maybe you want to take where there's a 1% chance someone can win a $5 from waving at you. Or maybe you want to make it where everyone who waves you gets 0.01 Ethereum for waving at you. All right, sending is a core part of smart contracts and one of the coolest parts about them. So let's do it. To start, we're just going to give everyone who waves at us 0.001 Ethereum, which is $0.31. And this is all happening on testnet. So it's fake. Yes. So that means in the wave, we are doing something new here. So we have waves.push, we emit this, and then we have price amount ether. So it seems like ether here is a variable that we can use in Solidity, and then we require the price amount, get address, this dot balance. Okay, trying to withdraw more money than the contract has. Okay, pool success equals to message sender dot call value price amount blah blah blah, then required success, fail to withdraw. So I'm gonna copy this, I'm gonna go to my file Solidity. Where is it? Welcome dot Solidity, and inside the wave, just after the emit, we are going to paste this code. All right, then this is pretty awesome. With the price amount, I just initiate a price amount. Solidity actually lets us use the keyword ether so we can easily represent monetary amounts. Convenient, yes. We have some new keywords as well. You'll see the require, which is basically checks to see if some condition is true. Okay, so that means it checks if the price amount is less than equals to this, then good. Otherwise, this sends this message or maybe throws an error similar to this one. Okay. If not true, it will quit the function and cancel the transaction. It's like a fancy if statement. Cool. So in this case, we are checking, blah, blah, blah. How this works is when we first deploy the contract, we fund it. So far, we've never funded our contract. It's always been worth 0 ether, which means our contract cannot send people ether because it simply doesn't have any. Okay, we'll cover funding in the next section. That's cool about this is that it lets us make sure the balance of the contract is bigger than the price amount. Okay, if it is, we can move forward. Otherwise, it will kill the contract or the call. Then message sender.call value price amount is the magic line where we send the money. Okay, the syntax is a little weird. Yes, that's why I said okay. Notice how we pass the price amount. So we say value price amount and then we use this. Required success is where we know the transaction was a success. If it wasn't, it will cancel the transaction and we'll say this. Fund the contract so we can send ether. So we're going to fund the contract here in the run.js file. So we deploy the contract, but along deployment, we are assigning the value here. Okay, cool. So we do a couple of things here. First of all, we use this 0.1 ether. Then we check the contract balance using the wave contract address. Then we log that using formatting ether. Then we send the wave ourselves. Then we check the contract balance again. And then we log that. Okay, so a lot of things going on here. I'm just going to copy this, go to my file, first save this one, then go here, and this is where everything is happening. So I'm gonna quickly go ahead and save this. Alrighty, the magic is on this exactly where I go and deploy my contract and fund it with blah blah blah. Yes. Okay, then I do utils format ether to see if my contract actually has a balance of 0.1. I use a function that ethers give me called get balance and pass my contract's address. Okay, finally we need to run this, so we create the artifacts. So we are going to run this file. You'll see run in a bit of error. Non-payable constructor cannot override value. Yeah, here we have non-payable constructor cannot override value. What this is saying that a contract isn't allowed to pay people right now. This is a quick fix. We need to add the keyword payable to our constructor in the Solidity. Okay, so we go there, we go to the constructor, and then we say payable. And if I run this again, this should run, hopefully. Yeah, it's running. Good. Cool. We just sent some Ethereum for our contract, big success, and we know we succeeded because the contract balance went down from 0.001 to 0.009. Exactly, so contract balance was 0.1 first, but then we waived a message, then we got 0.0999. Cool, cool, cool. Update the deploy script to fund the contract. So we are going to update the deploy.js with this value as well. I think that's probably the only change. Yes. So we go to deploy there, and then we say, is it portal? No, wave contract deployed. Yeah, this is the one, and that should be good. All I did was fund the contract exactly. Now we just need to run this. So it deploys our contract to Ethernet or test Ethernet. All right, let's see. Deploying contracts with this account balance is blah blah blah. We got a web portal address. Let's test this address. So we search this, we get it, we get contact creation, and there is the value. Yay! So that means that it's working as it should. Good, good, good. There's something about the actual ether to fuel your contracts, right? Take a look at this link to see all of the code. Submit your ether scan. Yes, please. All right. Did we finish section 4? That's good. So next lesson, randomly pick winner. This is the one that we need to work on. So generating a random number in a smart contract is widely known as a difficult problem. Okay, we need to do two things: randomly pick a winner and then create a cooldown mechanism to prevent people from spamming. All right, so what will happen is that we pick a winner, we send them ethereum money, then we wait for a while before we can do it again. So think about how random number is generated normally. When you generate a random normally in a program, it will take a bunch of different numbers from your computer as a source of randomness, like the speed of the fans, the temperature of the CPU, and the number of times you have pressed L at 3:52 p.m. since you have bought the computer, your internet speed, and tons of other numbers that are difficult for you to control. It takes all these numbers, they are random, and puts them together into an algorithm and generates a number that it feels is the best attempt at the truly random number. On blockchain, there is no source of randomness. Everything the contract sees, the public sees. Because of that, someone could game the system by just look at the smart contract, see what the numbers relies on for randomness, and then the person could give the exact numbers they need to win. That means what we are doing. Let's check out the code below. So in this one, what are we doing? We have a seed variable. We will be using this below to help generate a random number. Okay. Then we go below, then we do something like this. So we have a seed which is using block.timestamp plus block.difficulty and divided by 100%. Where does this block come from? It probably comes from blockchain itself. Then when we have the seed, we go and here we push the wave, then we generate a new seed for the next user that sends a wave. Okay, so this time there's a new seed. Then we check if the seed is less than equals to 50, then that means that the user won, which means seed is less than 50. Then we say user won, and then we send the price amount, and then we do that. Otherwise, we are good. So, okay. So I'm going to copy this code and paste it there. Looks understandable so far. So I'm going to go to welcome.sol, and would I replace all of this? Yes. So one important thing here is this seed is a random number. We take that number, and then if the chance of user is less than 50%, we can also say like greater than equals, but it's exactly the same. Then we do send the money, otherwise we don't. Okay, sounds good. So we save this. Then let's move forward. Let's make sure it works. Here's my updated run.js. In this case, I just want to make sure the contract balance changes in case we were the person who waived one. So in this case, we generate the same thing. We do deploy, get the balance, we get it again, then we do wave 1, wave 2, contract balance, all waves, log always. Okay, so I'm going to copy this till here. I'm going to go back to my code in the run.js, save this, and now we can run the command again. So we need to run npx red node hard hat run scripts slash run.js network. If I just do that, what would happen? Run.js. So this should start this compiling, finishing, and then we should see it. All right, so we see some logs. Let's have a quick look at them. The compilation finished. We have constructed the log. Then we had added the contract. Contract balance by default was 0.1. Then we got some user who waved at us. We generated a random number that was 79. Then we got another random number which got 66, and now we got 0.1. So here no one got the money. Let's run this again. Maybe this time we will get someone who gets money. So generated is this time it was like 50 and 80. Let's run this again. There we go. So now we got a random number 73, no change, but then we got 7. So we sent that money to that person. You see the message 1, and then we see the contract balance. Good, 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 good. Awesome. So now this looks fine. Now adding a cooldown. How do we add a cooldown? Let's see. So we had a seed number u in 256. Then we have a mapping. I think this is the last one. So this is an address u int mapping, mean I can associate an address with a number. In this case, I'll be storing address with the last time user has waved with us. So that means we would have each user's address and then the last time they have waved at us. So we can see if they have waved us right now or close to the current time or not. So we can copy this code, go to our welcome Solidity, close this guy for now. And is it above the constructor? Yes, it is. So here we are going to create this mapping. Then we have the seed, that's fine. Then here, when someone waves at us, we add this. So we need to make sure the current timestamp is at least 15 minutes bigger than the last timestamp. Okay, good, good, good. So here, I think even before everything we need to do this or no? Last waved add, yeah, exactly. Update the current timestamp for the user. So then update the current time for the user. So we save the last waved add message or sender, which is the Ethereum address of the person, and then block.timestamp. Then we got total waves plus equals to 1. That's fine. Wave.push, that's also fine. We're using block.timestamp for this one. Yeah, it's fine. Okay, then we got the seed, price amount, console log, this, new wave. Yeah, the rest of the things are good. I think just the mapping thing was there and we are good. So now we are going to run this and see how this works out for us. npx hard hat run script slash deploy js network rinkyby. So we are going to deploy this and then we are going to see if this works. Deploying contract, account balance is blah blah blah. Then once this is deployed, we can try to see by waving at that and then we can see if there was a transaction. So we deploy this and see the error message if you got to try wave twice in a row, how without waiting the 5 minutes. That's how you build the cooldowns. Send us etherscan link. So we got this address. We're going to go and change that into our code. Then we do a refresh and a save or refresh, right? Then we also go to etherscan. We go and search by address. So this only has, I think, one internal transaction, that is deploying the transaction. So we did deploy it. Did I make it correctly? Wave portal address, yes. Now we are going to try to wave it. And here we got, let's say, a new wave, and then let's say wave sign here. So if we do this, let's see what happens. And you know what I want to do? I want to also have these waves console logged as well. So I would do something like console.log so I can see each wave, right? I'm going to copy this, save this. Let's try this out. So I'm going to paste this wave, and now let's see. Confirm. It's mining right now. Transaction confirmed. There we go. So this one got a wave, right? And now you see here we got the address, a new wave, the message, big number, message, timestamp, waiver. All right. Now the thing is, did this person win or not? How can we check that? Can we check the logs somehow or no? Transactions, refresh. So we got some transaction. We got contract creation as a transaction. Then we got wave that happened, but there was no transaction at all. Can we try one more and see if this works for us? A new wave. Let's see. What happened? Unpredictable gas limit. Cannot estimate gas. Transaction may fail or may require manual gas limit. Okay. So the transaction failed. That means, oh, because we are not allowing the user to spam. That's why. So this transaction was rejected most likely by Ethereum. So they cannot spam us. So if I refresh now, would there be a transaction failure here? No, internal transaction. We got 0.0.1 ether, someone sent it. 1 minute ago, transferred 0.0.1 ether from this guy to this guy. Yay! So it seems like we already got it. Click to see more, gas fee, burned this ether, taxation savings, blah blah blah, method ID, function wave string. Okay, view input as UTF-8, a new wave, original is this. Oh, we got logs here. Hex, number, text, a new wave. Okay. Address. Interesting. Okay. 5 block confirmations. Okay. Number of blocks mined since. Okay. Alright, I think we already did one transaction, so that means we don't need to do it again. If I do it again, it's gonna probably cry and say don't do it. If I do it again, the blockchain essentially rejects it. Let's quickly copy transactions for this Etherscan, paste it into the portal, submit it, and move forward. Now we are at the section 4. Finalize your UI, make it your own. Spend like 30 minutes on this if you want, highly recommended. By the way, we are testing. You might want to change your contact's cooldown timer to like 30 seconds instead of 50. Yes, please. Okay, can we say 30 seconds? Ooh, nice. Yeah, so I changed it to 30 seconds. Okay, yes, let's do that. Last wave at. So we got this guy here. So let's say maybe 10 seconds. I mean, why even 30 seconds? Or yeah, let's do 30 seconds. Because I think it takes about 5 to 6 seconds at least for the transaction itself. So now that we have done this, we need to deploy this again. Once we do so, we can copy the new address and then try it out. All right. Setting gas limit. When you try to wave now, you might notice you sometimes get an error that looks something like out of gas. Why? Well, basically, MetaMask will try to estimate how much gas a transaction will use, but sometimes it's wrong. In this case, it made more difficult by the fact that we have some randomness involved. So if the contract sends a price, then the waiver needs to pay more gas. Okay, since we are running more code. Interesting. Estimating a gas is a hard problem and it's an easy workaround for it. So the users get angry when a transaction fails, is set to a limit. So in our app.js, I changed the line that sends wave to this. Oh, okay. And now I have to deploy this again. That means, let's see, dot wave. No. Is it in the run.js? No. Where is it? It's in the run.js? No. In the app.js. It's in REPL. So dot wave. So wave font, wave portal dot wave message. So instead of just message, and I'm going to zoom in a bit so you can also see this a bit better. Go this, and then we can say dot wave portal contract dot wave message, but gas limit also. So now if I try to do a wave with the new address, it should be good. So what was the address again? This is the new address. I'm gonna go into my app.js, make sure to add the new address so we are not calling our own address with the 15-minute limit. So if I save this now, we will first not have any waves. So we say something like, hey, new wave, and then we wave at them. One of the things that we want to do is, do you think it would be a good idea to say that someone has won the Ethereum on the UI instead of just doing it on the background? Because right now we get a message, but we don't really show that the user has got the Ethereums or the user has won something. Maybe it would be a good idea to add that, right? So now we got this, the Ethereum transaction. So this Ethereum transaction did two things. One was contract creation, and then this transaction 22 seconds ago, this is our transaction. And if I do internal transactions, you see that we send 0.0.1 ether just around that transaction. So this, a couple of things happen, and then this transaction happened. Now, if I try to wave the it second time, it should potentially still work. So I can say like, hey, new wave 2, and we are going to confirm this transaction as well. Transaction in progress, transaction completed notification, and we got the new wave as well. Let's go and see. So far, I've seen every transaction being passed. Latest block, blah, 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 blah. No, I need to look at the transaction for my code. So I'm going to quickly copy the address, go there, print it. Now see how we have three transactions. This 27 seconds ago, and internal transactions. Oh, now you see there's no transaction of 0.0.1 ether, which means that this was the 50% where someone does not get money. So this is super cool. I like it. Validating the transaction. When your contract has been deployed and you're testing out with your UI and your wallet, it may be confusing at first time to determine whether your wallet account was successfully rewarded with the price. Your account will have used up some amount of gas, potentially have been rewarded with Ethereum. So how you can validate whether your contract? So obviously, what I think is, yeah, I mean, I already did that. So yeah, that's what I was thinking. We can add different things to this new wave emit, and we can pass this to the front end. Yeah, so that needs to change. Alrighty, let's see. We have to wait out for mine and refresh page, blah, blah, blah. Alrighty, there we go. So did it say check out my code here where I updated got get all waves in app.js? So we were talking about the get waves, get all waves, get all waves method. So get all waves, get all waves. Go there. Let's see. So in this one we got address timestamps message. I think we also need to update this. So let's see. So we updated the get wave, new date, wave message, set all waves, wave clean, provider, wave forwarder contract, get signer. All right, let's see what are we doing here. So get all waves method, it is this one, but listening for the emitter events. So when we say on new wave, we get a new wave, we set all waves with the new data. Then we say window.ethereum web3 provider, and then we say on new wave. Oh, all right. We are already doing this, but we are doing it in a different way. We are not listening to that event. Maybe we should do this. So far, what I've done is that whenever we send or whenever the transaction is completed, like when we send this, and in the end we just call the get all waves, and that essentially gives it back to us. All right, so we can remove this from here. We can use the official way. That's good to know. I mean, I will not say that, hey, no, my way is the best one, because it's probably not. So this is the one that we should be doing. Use effect. So we're going to use effect, going to use effect. In this one, we are doing wave contract on new wave, and then we use this. Cool. Is there anything else that's remaining? A note on GitHub: if uploading to GitHub, don't upload your hardhead config while your private key to repo. You will get robbed. .env for this one. Yes. Tetrarap, your NFT. We'll airdrop you your NFT within an hour, and we'll email you once it's in your wallet. It's running on a cron job. If you don't get it within 24 hours, please drop us a message and feedback and tag Alec. Okay. Go to showcase in Discord and show us your final product that we can mess around with. Also, you should totally suite your final project and show the world your epic creation. What you did wasn't easy by any means. Maybe even make a little video showing off your project and attach to that to the tweet. Make your tweet look pretty and show off. And if you feel up to it, tag build space. We'll retweet it. Plus, it gives a ton of motivation whenever we see people ship their project. Awesome. So now I think what we should be doing is, first of all, I do want to take the project to the next level, which obviously this tutorial has not done yet, and that is I do want to see or show the user if we have won a message or won a wave or not. Okay, so that means I think what we can do is we can say if we win the ethereum, then we show sort of an alert. Let's start small. This is sort of the formula I follow in all of my products, and that is start or calling it make it work, make it fast, and then make it beautiful. That is my logic of building anything. So let's make it work first. In Solidity, we are going to change the structure a bit, and we are going to say that this event is going to have a couple of things. It's going to have the address. This is going to be uint 256 wave number. No, it's going to be eth1, right? And then we can also say boolean, I think. So with the new wave, when we have to emit this, we can add those values, right? If seed has got that, then we do this, otherwise we do this. So I'm just coding something out of my mind. So let's see. So the message had ethereum 0 and false. This is good. In this one, we are going to add the price amount, and we are also going to add true. This should be happy in a bit. There we go. So now we are emitting this data that, hey, someone has actually won, right? So what I want to do is I want to deploy this now and show the user when someone waves. So we can say something like, first of all, let's deploy this to ethereum. Then we are going to take the contract address, update the contract address, and also we'll show this on the UI. Once we do so, then we can improve that by showing some sort of confetti, like, all party poppers. So let's do that. So I'm going to copy this guy. Was it copied? Now it is. I'm going to go up top, change the ethereum address, save this, and then we are going to change it a bit in terms of getting the waves. So each wave that we get, we do add address timestamp message, but we also should be adding like has one, and then we can do wave dot message, or we can also say ethereum 1 wave dot ethereum 1. Okay, so when we get those, we should get all of those. That's good. But the only time we will show that alert is when someone is using the application and that someone won the game, right? Or won it. And that can only happen when you do this new event thing on new wave, I believe. No, it can also be a bit different. So what I'm thinking is that when, let's say, person A has opened the application and person B also has opened the application, if person A adds a new wave, then person B who has opened the application will also get this new wave, right? because it's real time. So we need to understand that we need to check that this address is same as the user who has submitted this. Then we will show the confetti, right? Because we need to make sure that's happening. So I can open this, let's say, into a new one, just to make sure that what we are saying is not nonsense. It's actually true. So I'm gonna add this, kind of take it like this, right? Kind of close this. And then I need to go and check this out. So on the new wave, we get all those values: address, timestamp, message. Didn't I just change that? Revert my changes. What? Oh, there we go. So this is inside get all. Oh, okay, okay. Yes, 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 yes. All right, all right, all right. So we're gonna go inside on new wave, do this, and we get it from, so we console log on new wave from timestamp message eth1. So on new wave we get those values. So we need to not use wave.message but rather ethereum one, or we could shorten it down using this, then has one. Okay, all right. And we also say if the new wave, we are going to check the same thing right here right now, that if the from equals, where do we save the contract's address? Do we save that anywhere? See, where do we save the address of this person? So current account, yeah, there we go. We got current account here. This current account itself is this one. This current account should have the address itself. When we have these accounts, found an authorized account, and that is this, and this log we are doing, where do we do that? There you go, found that and account. Yeah, exactly. Good, good, good. So we have the variable in account. Good, good, good. So we can go into the new one, the new wave here, and we check, hey, if from equals to account and we have won the game and we have has won, then we check something like, we say alert and say you have won, and then here we can do the string interpolation and say you have won eth1 ethers, right? Something like this. So I think this is good. Can you try this out now? I think yes. So now we are going to wave from here. Is it also changing my code right here as well? If I'm opening this into multiple ones or no? Let's see. Oh, it is actually. It's real time. It's also highlighting it as well. Ooh, look at that. Dude, repel it. Awesome. So let's do that. So if I say hello and something like wave, then if I wave, it would ask me for the transaction. I'm gonna also scroll here so we can see it here in the real time as well. So transaction in progress. Let's see what happens. Unless it crashes, I think we should be good. Maybe it would crash. Maybe. So it's mining right now. Transaction confirmed. And there we go. We did not win anything, unfortunately. And interestingly, we do not see our new wave as well. That means our use effect is not working. Why? So we see on wave here, we get the on contract here. We console log a new wave. Did we get a new wave? Let's see. Retrieve total wave count. No, we did not get a new wave. Why did we not get a new wave? Oh, maybe I know. Maybe, just maybe, because we don't have the ABI. All right, so we need to do npx hard hat. What was the command again? We need to build it first. Store data on a smart contract. We need to first create this. There was a command called build something something. I think this is run command. The run command essentially creates the artifacts, right? I'm gonna quickly try and see if that's the case. So the artifacts folder, I'm gonna remove the contracts, greeter.sol. Let's run this first. Now we got an error, right? VM exception while processing reverted with reason. Wait 15 minutes. Okay, okay, that's fine. But did we create the contracts? Yes, we did. Now we got this. We got the db.json here, and this one should have sort of, what do they call the message type wave. So now I think there should be eth1. There you go. So we have this file here. We're gonna go to our wave.json, go to our utils, and inside utils we have waveportal.json. We need to update this. You see there's no eth1 here. That's probably why it's not working, but I'm not 100% sure. I'm gonna still try now. So we're gonna do a hey 2. Wave at me. All right, fingers crossed. All right, got the notification. Yay, we got a new wave. Look at that. We got the new wave. We added it to the view. This is the hey 2 now. So that was the issue, the wave JSON. Wave portal JSON was the issue. And now we got it here as well. Now, unfortunately, I think we didn't win because we have the new wave here. We got the new count, but we don't see the new wave or if we won. There should be some transactions which failed. Why these failed exactly? Gas target, 36% gas target. So that means I think this is happening because we are doing some gas used and then we got 36% is the gas target. And also there's a question of the wave itself. When we set the gas limit to this one, we are setting it somewhat around this, like 30,000 something something. Should it be like 300,000 something something? If I do this and try to wave again, would that fix it? So we got a new one here, but the weird part is that in app.jsx, we got this new one. But here it's failing, right? All right, let's put a breakpoint and then try again. It's a lot of time consuming. I absolutely have no clue. Maybe because it's creating a closure out of it. What? Maybe it's creating closure around current account and that's why it doesn't get it. So what we need to do is here we need to define current account because we're using current account inside. That's why. All right, let's save this guy. Let's try this out again. And I hope we will not see this issue again. I'm very hopeful that this time is not going to be having that problem because this current account, since we are using this inside the use effect dependencies, this might change and we should get a current account that has the right value. Yay, let's go react. All right, so I hope that you liked the video. If you did, press the thumbs up button, subscribe to the channel if you have not already done that, share this video with colleagues because this particular field, the Web 3.0, is amazing and has a lot of potential. Write in the comments what should I be covering next in this particular series, and as always, happy coding. I'm going to see you in the next video.